Hello, everyone, and welcome to another episode of Simplifying Network Automation with NetGrew. I'm your host, and today we have two special guests, Milaitis and Nikos Kallergis. Welcome, guys, both of them for Greece.
Hey
I'll let
there.
them introduce themselves. Nikos, why don't we start with you?
Sure, of course. Hello there. Thanks for the invitation and having us here. I'm Nikos. I live and work in Athens, Greece, as you said. Career-wise, I have been a network engineer for almost 20 years now. Multidiscipline, I want to say. I never stuck to one thing. I have done routing, switching, firewalls, wireless, IP telephony. I have been pre-sales. Not very proud of that. But that was what gave me the time to start diving into automation, maybe 8 years ago, close to 10 even. And for the last 10, I have been very enthusiastic with automation. Has been my primary focus for 5 years now, 3.5 of which I'm with NTC. My current role is a network automation architect with NTC. And I guess that pretty much rounds up the introduction for me.
Nice. And NTC is Network to Code, right? Just making sure that
NTC is
folks know.
Network to Code, yeah. We
All
use
right.
the acronym a lot. Yeah, sorry for that.
No worries. Cool. Welcome. Happy to have you here, Nikos. And then Michael, welcome. Did you want to say something, Nikos, before?
I do. I just saw Ioannis jumping in,
Yeah.
and huge shout out not only for helping in setting this interview up, but for his contribution in everything that we will discuss during this hour.
Yes, Johnny's big thank you for everything. Johnny's a great friend, so super happy that he's joining us and looking forward to meeting him. I mean, we've met in Cisco Live Amsterdam, and that's how we kind of started this conversation with having you guys on. But yeah, Ioannis, thank you for everything that you do.
Thank you, Yanni.
And then Michael, welcome. Tell us a bit about yourself. Like, what do you do?
Thank you very much for the invitation. I'm Milaitis. I'm a senior automation consultant at Network Code. My background is mainly in large-scale networks. I spent over 10 years working in the network engineering department of some of the biggest ISPs in Greece. Over the past few years, I shifted my focus to network automation. In my previous role, I built and led a team focused on network automation. We're working on projects such as network notable deployments, ACI automation, NSO services, and things like that. And one of the highlights was the delivering of the automation solution for the Greek state in collaboration with Network Code. We also designed and implemented a hybrid network solution, ACI automation frameworks with CI/CD pipelines, NSO services for a major service provider in Greece. And I'm really proud for the team that we built at the time. So yeah, that's it, my introduction.
Nice. All right, so both of you guys, right? Well, all three of us, pretty much network people at heart, have been around for a while, and then kind of jumped on the automation bandwagon. How did that happen? Like, what made the transition for you, right? Because I mean, we've been doing networking for many years, but then at some point, it's like, okay, something must have happened for you to say, okay, automation, I kind of see it as valuable, let me get on this. So what was the trigger for each one of you to kind of adopt automation and start working with it?
Michalis, you started touching on that. Please feel free.
Okay, so actually, in my previous roles, in one of my previous roles, as I said, I worked in service providers, so we had very frequent maintenance window, and most of our operations were done outside of regular working hours. And what I realized during that time is that no matter how careful you are still human, and mistakes happen. So when you're working on a live network serving thousands and thousands of customers and important customers like banks, those mistakes can turn into major problems to you. If you have worked as a service provider, you can understand me. That's when I started using automation to generate configuration needed. So my first automation, if you can call it automation, it was Python script with print commands. Uh, it really helped me reduce errors, and that when I began to understand the true value of automation, not just for configuration, but for also for validation. Because when you're migrating an interface of a core routers that serves hundreds or thousands of MPLS circuits, it's impossible to test it manually. So bringing automation to a situation like this, even with very dummy solutions, like very dummy Python scripts, you can realize how essential it is for efficient and also for reliable network operation. So that that's shift my focus to automation, and I realized the importance of it.
Nice.
Damn,
What about you, Nikos?
I should have gone first. My story is silly. So, one of the things that is crucial, I believe, for incidentally, both Michalis and my story, is that we were both trained in the same university. We were not friends at the time, but the focus of the university was developing, coding. So, for 4 years, we had pretty large exposure to the world of coding and stuff, and I believe that played a key role going forward. Incidentally, when I finished, we have these apprenticeship programs in this
Mhm.
university that by the last semester they send you to a company for 6 months, and there I met a now common friend, Manolis. Hey, Manoli. Um, and I was fresh out of the school. I knew, C, Sharp was not a thing at the time, it was plus plus.
Mhm.
And I was dabbling into Java. And he took me by the hand. He was the lead engineer in the oil company that I went for my apprenticeship. And he decided that it was a good idea to create an ad hoc NMS with Microsoft Visio, Excel, Perl, and some Visual Basic. And we did do that. It was hilarious, of course, but it was a really good exercise. And by the end, we had become so arrogant with what we had just done that we started even sending commands to switches. I'm on the reliability thing that Michalis also touched on. I was able to enable VTP in a serial fashion. There was two big rings in this installation, oil rig kind of, and I was able to overflow two huge tanks because the switches that had the controllers on them got completely bricked because I was doing VTP without spanning tree properly. And so I learned that automation is really consistent in making mistakes. That was my first dive into automation. And now, reality. After that, I started working as a network engineer. That was a huge inspiration. Around 2015, maybe a little bit earlier than that, people started talking about this new thing. The big names that I had been reading before was Ivan Pepelniak with IP
Mhm.
Space Portal. Um, I guess he was the biggest inspiration for me. But also Matt Oswald, he had this incentive from the Juniper side, creating some labs around automation, and obviously Jason Edelman and Damien Garros that
Mhm.
were huge. Also, just Vandera. And well, when I joined in Networks to Code, it was a huge thing. 5 years after reading these, almost extraterrestrial people knowing so weird things that are networking, but also not networking. And I interviewed for Damien Garros, my first meeting with Jason, and a little bit after I met Josh. and it was like that. Um, for me, the topics of network engineering, I have touched on all of them, so I was a little bit bored. In the company that I worked at the time, I was a sales engineer. That was apparently not a good choice for me. But as I said, that gave me the time to dive into that. And this is how it came to be.
Nice. So with a bit of free time, right, and trying to make the
Yeah.
work easier for you,
Yeah.
and there you go. There's the triggers for automation.
Mostly yes. And a lot of nice words around it. At the time, the things were SDN, a lot of hype behind that.
Yes, open
Uh,
flow is gonna put us all out of
Open
business.
flow, yeah.
Oh my God, yes.
Open flow was huge at the time. Everyone was talking about that. I was so angry with Mr. Pepelniak for bashing at the time. I thought that it's the future. How can you say that? And it was pretty much at the same time that there was a guy commenting in his comment section that called him grumpy old man on his ivory tower. And he was so sarcastic about that. I loved him so much. And at that moment, I started thinking, maybe he's right about that. Maybe, centralized control does not make that much sense. 2 years after, the momentum of OpenFlow kind of died. But there were still some really nice words. We were talking about Lisp, OTV, that played their role. It's not pure automation, but the whole overlay stuff that pretty much ended up in VXLAN and VPN was another
Mhm.
direction that was really interesting. So much complexity that it invited automation. And I guess that was one of the things that, also played a huge part into that.
Yeah, I remember exactly because I was reading also Ivan's blogs. I still do. I
Yeah.
remember
Yep.
exactly what you're talking about when everybody was on the SDN bandwagon, and he's like,
Yes.
"Hold on a second, this is not gonna
Yes.
scale, right?" It's like
Yeah.
this
Yeah.
is not gonna work.
At the time, I was a pre-sales engineer, so I was selling the fixes and all the similar ideas that Cisco had at the time, central switches with remote line cards and so on, like crazy. Everyone was so enthusiastic about that. And it was a really cool solution at the time. But yeah, scale, yeah, comes back to you, I guess. Yeah.
Yeah, it always does. All right, so then let's talk a bit about this project because I mean I know you guys have been working on this with automating the Greek government, all the infrastructure, and I mean this is a huge project, right? We're talking about hospitals and schools and everything, the mayor places all around Greece. So how did you get to work on this? Who started this project first of all? How did you get started and how did you get involved?
Mihaly, do you want to
Actually,
begin?
makes
Mhm.
sense to start show the some slides that we have prepared in
Okay.
order to
Oh,
dive into
sure.
the. What do you
Yeah,
think?
we have two or three of them. We can. May I share my screen? Cool, cool. Let
Let's
me.
see. So huge setup, right? I mean, is this the largest network increase
Uh,
besides
Actually,
ISPs? Besides ISPs?
yes, beside ISPs, because it involves more than 35,000 branches of the Greek state. Actually, this project involved deploying a one network to interconnect all of the public sector POPs, which are essentially more than 35,000 branches, included schools. And also, these branches are grouped by tenants, since each tenant represents a separate administrative domain. So it's I believe it's a huge network. If you exclude service providers, I think that is one of the biggest networks that you can see in
yep.
Greece.
Yeah, and some history behind that. In Greece, we had a public sector ISP. It was called OTE. It was run by the government until the mid 90s, if I'm not mistaken. And by constitution, they had responsibility to provide circuits for all the entities of the public sector in Greece.
Hmm.
At some point, it was privatized. I am not exactly sure if I recall correct, just slightly before 2000. And this is how the Greek state version 1 project came to be. It was way smaller. Um, it began at 2001, if I'm not mistaken, and it covered 5,000 points of President Michali, or 10, something like that, right?
Yeah,
Yeah, yeah.
5,000. Yeah.
Um, it was way smaller in impact and size, of course. And 10 years later, everyone understood that it was time to refresh it and make it larger to include all the other organizations that were left outside in the first iteration. So around 2010, a committee started designing what eventually came to be the Greek State project. A tender came out. Thank you, Ioanni. Uh, a tender came out around 2014. Um, it was, I think, that went on for almost 4 years after the bid was won. Eventually, to cut the story short, most of the big integrators in Greece, among which the two that Michalis and I were working for, formed the union because of the size of the project, and split the project in between them in order to start executing it. So it was put in action. The wheel started spinning around end of 2018, and this is where we come into the picture. Uh, Michalis was assigned the lead role for the networking part of the network, and I was assigned the lead role for the automation part of that. Um, the guy connecting the two was a colleague of Michalis, Tassos, really crucial into everything that will come from here on. And we started forming a team of 7, 8 people, discussing around how we can implement Michalis design into automation. Because the whole thing was procured in 2014, the solutions were, let's say, not optimal. Some of the Cisco equipment that was to be bought was end of life, so it had to be, you know, refreshed. And the most crucial part was that of the network controller. The first version of the Greek state was based on checkpoint firewalls for the most part. Very simple specifications. For those not familiar, checkpoint firewalls have a management server that
Hmm.
sits in the middle and pretty much configures the gateways that are in the points of presence. So you have a centralized control and some goodies that come with the closed source nature of a vendor like Checkpoint. Um, we did not have that. It was Cisco routers for us that had to also double as firewalls, and we had to somehow manage them centrally. There was a software that was somehow hot around 2014-15, but 5 years later, it was nowhere to be found in the market. It was closed source. It was licensed per device per year, which means that the costs would be pretty large. So we were, in a strange position. And one afternoon, Tassos, friend of ours, called me, and we had a meeting afternoon. And somewhere in the third beer, I want to say, we had this revelation, like, you know what? Let's let's do it with Netbox or Notobot, get some services with the money that we would put for the licenses, and we will have a really cool open source solution, really proud of us. We will become better engineers, and we will the whole team will be lifted, and also, you know, leave something nice behind, like an open source big solution, no fees going on for all these organizations and so on. So we had this big idea, and this is where Ioannis comes into play. He was the middleman for contacting Tasos Karaliotas. Yes, that's it, Zinon. And
Exactly.
Ioannis
So
contacted. Yeah. Uh, and Ioannis contacted NTC for us. Um we came with a good offer to them, like we have this much money that we would give for licenses. Is it enough to do the managed services, professional services, sorry, to set this up? We found a middle ground and we started doing that. Yeah.
And this was Nikos. This was like around 2019 time frame wise.
Late 19, Michalis, maybe early 20.
with
Yeah,
20.
we got an approval from the authorities. They were enthusiastic. Luckily, the people that were reviewing our change proposal were big proponents for open source. And they really liked the approach that instead of going with a proprietary tool, we would go with open source, making everything more supportable and maintainable going forward. And once we got a sign off, we embarked on the journey to start designing the automation solution with network to code. Yeah, pretty much
Okay,
that's the story of how we came to the project.
gotcha. And on the network architecture, Michael, were there any changes compared to the original design? I would imagine that yes, right? Because back when you started the design in 2010, I mean, things have evolved also. So by 2020, did you have to re-architect everything or like just small changes?
There
Hmm.
are a lot of changes. I wasn't involved in 2010, so I get involved in the recent redesign of the project. So there are lots of changing. Some device models have
Hmm.
changed. Also, the networking solution has changed. Some VPN architecture that we used. So we redesign everything from scratch based on the new requirements, because also the requirements have changed since 2010. So we redesign everything from scratch from the beginning.
Wow. All right.
The Yeah, it was a very interesting project. I can say we learned lots of things, new things.
Yeah, and what also made it a little bit even more interesting is that 6 months after that, once we got the sign off to go open source, I jumped ship first and joined NTC. Luckily, my first project was the Greek state, so I continued doing pretty much the same thing, but from the NTC side. Even more likely, Michalis was moved into my position. So we were
Yeah,
peering as we were pretty much the lead engineers from the network to code side and from the Greek state side. So it was a really easy communication. We have a rapport. It's easy, and we had a really cool team around us too. Not big one, 4 or 5 people. Um, And yeah, this is how we started working on providing these services pretty much. Yeah.
Okay, so services provider, I see here internet access, then voice over IP, DNS, email, web hosting. So pretty much everything for these locations, right? From a network perspective.
Yes.
Uh, okay.
yeah.
All right. So then you guys, wow. I mean, yeah, having to architect everything. having to change, moving from this checkpoint license model that's going to cost an arm and a leg to going open source. I mean, these are massive, massive changes, right? And like big decisions that you had to go through.
Yeah.
Okay, so then what happened next? I'm on the edge
I
of my
would
seat over here.
say that it was very fun. You make it sound like it was anxiety ridden or anything. At the time, at least in my head, Mihaly, please keep me honest here. The idea was that once we have this done and set, first we will be very proud of what we will have accomplished, but we will have positioned ourselves in a really good place going forward as engineers. Like
Hmm.
we will pretty much be in the place where our icons, let's say, did do some name dropping before, are.
Hmm.
So that was the motive, at least for me, what pushed me forward.
All right. So then, how did you approach this? Right, you decide we're providing these services. We're gonna go with
Yeah,
these tools. Michalis does the architecture. So
yeah.
then, how do you approach it? How do you get started with this? Oh yes,
Requirement
let's see the
gathering,
requirements first. Yeah.
exactly. This is how we started by gathering the requirements, pretty much. Greek tenders tend to be overly verbose. The one that allotted this thing to the Union of Integrators was around, I don't know, some thousands of pages detailing every single aspect of what has to be done. Plus, it was already 10 years old, so, out of fashion somehow. So we started a round of gathering information from the documents, but also from the union and companies that were to run that. Um okay, I'm a little bit ashamed of that, but this is what actually happened. Network to Code has a program called SEIDA. The idea is that through a series of interviews, we're trying to formalize what is to be done and provide the blueprint with architecture, especially focused on automation, but also around the workflows that we want to implement with said automation. So, gathering the requirements, uh, we started pretty much. Okay, I will not stick to the requirements. The demo that Michalis will present later pretty much goes through all that. There were a lot of requirements, though. Okay, that's the point. And eventually we came down to an architectural document around 100, 200 pages that also details the tooling that we decided to use for that. Uh, we went with Notobot with no actual second thought. It was the involvement with NTC at the time. It was new and very flashy. So we adopted it. And with everything that is database based, you come to realize that usually, okay, integrity is cool, but you need something like Git.
Hmm.
So for our sources of truth, it was Notepad and Git, and a lot of knowledge went into the Jinja templates. That was to a very large extent Michalis' work, really elaborate, intricate Jinja templates to do this whole management of Cisco devices. For the automation piece, it was mostly Python in the form of notable jobs and plugins. There was a big telemetry piece centered around the Elastic Stack. The main reason that we went with that was that there was a requirement to do SOC, kind of.
Hmm.
So Elastic did provide that. We used GitLab for source control and CI/CD, and Haskell Vault for secrets management. All these pretty tightly integrated as a platform altogether.
Okay. So see, of course, some familiar tools in here. And Socrates says OpenWRT. Lol. No
Yeah.
OpenWRT.
No, it was mostly Cisco, but not the Linksys variety. Yeah.
All right, cool. What next?
Year and a half of involvement into setting up Notebot and trying to pretty much standardize what we had to do with 35,000 sites. Michalis knows this piece way better than I do because at the time he was really hands-on, fit in too. But yeah, it started with this big idea that we will separate the points of presence with t-shirt sizes, like small, medium, large, extra large, and that will be the only differentiator. Every t-shirt size will get the same equipment, the same circuits, the same configuration, and so on. Obviously, this is in the fantasy world. It's not realistic. And so we started making exceptions until we came to a point where we had to somehow model these exceptions and be able to do overrides based on multiple levels, pretty much. The type of the organization, be it municipality, a school, a university, police station, you name it. The sizes, telephony sizes that apparently we came to understand are different from the network sizes, and drilling down to the site level specifically. So, just to show that, I will very quickly go. Yeah, the idea, and that will also explain why we're doing that. Um, Due to contractual reasons, and I don't have a better explanation for that, this whole thing ended up being three systems. What we call InfoSoc, short for Information Society. That's the authority that pretty much designed the whole thing, or at least played a very central role. There was another system doing hostmaster slash IPAM tasks. And this is the piece that we were mostly working on, CSMS, short for Centralized Security Management System. Okay. Each system provided information to the next one. So from the first, we got sites, prefixes, and inventory. From the hostmaster, we enriched that with VRF and tenants. And in CSMS, we generated the actual artifacts that would eventually lead to the configurations. The reason I'm saying all that is that because we were receiving the sites, inventory, and the base prefixes, the hostmaster level prefixes from this hostmaster entity to CSMS, we had most of the information needed in order to do what we call data generation. From the minimum information, generate all the resources that are in this funny box here. So, data sync, the blueprints, I will show them right now, led to data generation, the artifacts like devices, interfaces, and so on in Notebot. From there, populating Jinja templates in order to drive config generation, and then a really elaborate way that Michalis and some of our colleagues, Christian, Xenia, worked on to do the GTP on that. I will leave the bottom floor for now, and I will go to the actual blueprints. All right, so I hope size is okay. This
Can
is
you
the
zoom in a bit,
actual.
Nikos, please? Just like
I
a
can
couple
zoom
of.
in, of course. Yes. Yeah, let me try that. I hope that's better.
That's better. Yes.
Perfect. Okay. But yeah, no worries. It's not something overly useful. The idea here is that this is the actual repo of blueprints that we're using in order to do data generation. The t-shirt sizes are under access class. This is the internal code we used for the size of the points of presence. And these were the t-shirt sizes that I mentioned before. Well, I forgot asymmetric. That means DSL, very small points of presence that used asymmetric DSL, ADSL. And then we have small, medium, large. The idea here is that we were defining in YAML format what was to be created. So for the very small ones, that's one rack that is common for both wiring and networking. Some VLANs, very simple structures, a device with its interfaces, and so on. Whereas for a larger, we have separate racks, VLANs, devices with more interfaces and circuits, and so on. We have a lot of overrides. So, for example, the asymmetric tenants are not one size after all. They have intricacies. The metropolitan area networks have some different way to connect to the internet. There are some that don't get a switch, have enough ports for them. There are some others that do have switches, so we have extra VLANs, extra devices, and so on. And the idea is dictionaries that are merging as we go to the more specific. And eventually, with this structure, we're able to do standardization and also loyalty down to the site level. I'm doing spoilers now. This will be the demo that Michalis will be delivering. So for that's me. I had forgotten about that. Yeah, the idea is that for the specific site, this is our lab, so it has some special attributes. We can override on the specific, site that has this and that needed interfaces, ranges, and so on. So yeah, that was the first piece of the implementation, synchronization with other systems, and definition of what is to be created in Autobot, what we call data generation, with these YAML structures. These live in a repo, and Autobot would pull from that and run some elaborate jobs that we managed to create in order to do the data generation. I can talk for hours on that, but I really believe that the demo that Michalis has prepared is way more interesting than my face spewing words. So, if I may, I will stop sharing. And Michali, all yours.
Okay, let me start sharing.
All right, so we have the templates defined, right? So then Michalis takes those templates, loads them up in Autobot, and then creates configuration for every single site.
The sites that we choose, pretty much.
Okay.
Again, the size of this thing is pretty huge, 35K. So there was no clean phases. Like we did this thing first for all of them, and then the next one. Everything was parallelized. So while we're getting information about new sites, there was a discovery with field engineers before they were onboarded. We were running data generation for the existing sites, and then these were being actually installed, GTP and so on, and the pipeline ran again and again. Tens of operators doing that up to the day, if I'm not mistaken. And with that, I will stop talking. Michali, all yours.
Something to add on top of what Nico said is that network design was still in progress when we started the automation solution. So we should be very flexible to integrate new requirements and new features. And that makes the project environment more complicated because we should always keep changing our solution to fit the networking team's requirements.
It's like building a car while you drive it type of thing, right?
Something
Very
like
good
this,
analogy, yes.
So yeah, this is a demo, a lab environment. As you can see, there are no devices populated in our Autobot instance. What we have here is the data that have been synced from the other system, as Nikos described. So we have a location This is our site. It's a demo site. The site has been populated, has been synced from another Notebot instance that is the source of truth for location informations. This site at the time has only circuits. So we have one circuit. We have prefixes, which again have synced from the IPAM Notebot instance, which is a different Notebot instance from the automation platform. And also we have information about the device in a JSON format, like the device serial number. So based on this information, the location, the circuits, the prefixes, we're going to run a job from our Notebot instance, and this job is going to populate the device. So here, when we run the job, we expect to see a new device. So we're going to, what a Notebot job is actually is a Python script where you can write it through Notebot. And this job is going to create, based on our design, the network device. And based on this network device populating Notebot, we're going to build the network configuration. So I'm going to generate the device object, and also I will create the DNS records, because that was a requirement to, when we create a new device, we should automatically create the DNS record in the DNS server. So I will run the job.
Mihaly, one tiny warning. I guess your internet connection is not perfect, so there are some visual artifacts when you are scrolling very fast. So
Okay,
if you may scroll slow. Okay.
sure. Sorry about that. I don't know
No,
why.
absolutely no worries. It's understandable. Just when you scroll. Yep.
Okay,
Thank you.
so we run the object generation job. So the
Mhm.
device has been populated. So here you can see the device.
Okay, so it's an ISR 1121. It shows
Yeah,
up there.
you have the serial number, the device type, the rack, the tenant, and also you can see the interfaces populated with the IPAM information based on the prefixes that we define, and also the circuits has also been terminated in the correct interface. So we have also a circuit termination here. So what this job did, create the device, create the interfaces, and now we are able to render our digital template and produce the device configuration.
Mihaly, before you go into that,
Yeah,
if you may, I know I said please don't scroll, but yeah, okay. If you may go to Gigabit Interface 7017,
yeah.
that incidentally kind of demos how the overrides that we were discussing. Uh, so if you may scroll
Okay.
a tiny bit
A,
further up,
a bit
yeah,
more, yeah. So then we see
there it
it
is.
is.
That's the Lord of the Overrides that we saw
Yes.
in the YAML documents just before. So for this specific site, the data generation took the overrides into consideration and did a very silly configuration for Gigabit Ethernet 7.
Okay. So now I'm going to run the generate intended configuration. With this job is going to render the digital templates. So I will choose the device and run the job, and hopefully we, through the device, we can see the intended config, the config based on our design that should be on the device. So here, let me refresh.
So you're creating all this before even the device is deployed to the site, right?
Yeah,
You just load it up
exactly.
in Autobot, you have the serial number already added, you generate the configuration. The device is not even there, for example. It's just being, ordered
Yeah,
from Cisco. And once it gets there, you start the ZTP process, I would imagine.
Yeah, exactly. And
Okay.
Michalis
and
will demo that. Tiny note on what you're asking. It was a really big thing that we did not want to go through the staging phase because we did the calculations and the logistics of storing, staging, sending, and doing the ZTP process for 35,000 devices were nightmares. So instead, we had to do this whole process that Michalis demos, very independent, let's say, from the physical aspect of the device. Pretty much the story is that from the Cisco factory, the devices were delivered to the point of presence, and they were ZTP'd, as Michalis will show, directly. So, yeah.
So actually, this is the device configuration. This is actually the render. So what we need, why priority requirements, was to eliminate the need for manual device staging. So we need to develop a zero-touch provisioning solution that would allow field engineers to automatically get the device configuration through Autobot. So what we essentially need to do is to get the device configuration based on the serial number. So I will show you this API request that we. So this is an API request to Autobot. Our input is the serial number of the device, and if we send this API request, we're going to get the full device configuration, and this. Okay. So this Autobot API endpoint can provide the device configuration, but the requirement was to get this device configuration directly from the device. So you cannot do a curl like this from the device. So what we need to do is use the copy HTTPS command. So the requirement is to use a command like this, copy HTTPS running config, in order to get the device. So a field engineer with a single command to get the device configuration through Autobot. So what we did is we create this URI. I'm going to get the configuration to a test CFG command just to not affect the device configuration. What this URI is encode the token and the serial number of the device. This get interpreted by an intermediate reverse proxy, which transform it to a Autobot API request. So this copy HTTPS command will bring the device configuration of the device. So this will take a couple of seconds because this will trigger the Autobot jobs to run, produce the configuration, render the templates, and then send them over HTTPS directly to the device. So with one command, you can get the full device configuration, the intended configuration, which is produced based on our device, on our design, to the device. So,
Gotcha.
I don't know if it was clear or if you want to ask something about that.
Yeah, I have a question for the previous step, right? When you instantiated the device in Autobot, where'd you get the IP addresses from? Is that part of the Autobot job? Is that a database in the backend? Like, what's going on there? How did you populate those, like, IPv4, IPv6, all those VLANs?
Yeah.
With blood, sweat, and tears. Yeah. But yeah. It's automatically generated. Yeah, please, Michael, sorry.
Yeah. No, as I showed you, the prefixes was there.
Yeah.
So each prefix has a role. So if I go to prefixes, so we have those prefixes. Each prefix has a role. This is a one prefix. This is a datalan prefix. This is a loopback prefix. So based on the prefixes assigned to the specific site, we can produce the required IP addresses.
I see.
And we get those prefixes from the IPAM Autobot instance. And just to conclude with the ZTP, so this command, the copy HTTPS command, get finished. So I can show you that the test.cfg file has the running configuration of the device.
But yeah, as for your question around IP addresses, not only this IP addresses, but also circuit information, a lot of credentials and stuff like that. There is a lot of logic hidden in the blueprints that we tried to show before. So in the most complex situation, a really big organization would get /21 or something, and that's the only information that we have, along with the serial number of the device. From that, we can extrapolate the devices, the interfaces, the prefixes from the 21 to the /24s, 29s, and so on, what has to be assigned to the circuit interfaces, credentials. Anyway, this job that Michalis clicked the button and ran in 5 seconds took us weeks to do.
Months.
And months even, yeah. And it was in progress for even many more months after that, because the changes were coming here and there. So yeah.
So we have the intended configuration. Now we're going to get the backup configuration, which actually is the actual configuration of the device. So this job logins the device and gets the actual configuration. So one job renders our data templates, produce the intended. This job gets the actual config from the device, which is the backup configuration. And then we need to perform configuration compliance. So we need to check the actual device configuration with the intended and see how compliant we are with our design. So this is the configuration compliance job.
So just Michalis and me have done this so many hundreds of times that, yeah. The story here is that we did automate a huge part of that. When we're running the ZTP, the state of the device is 100% what we intended it to be. But one of the main challenges of automating such a large network is that you need a lot of engineers to operate it, and not a lot of them are on board with automation. So it's really, really common, and a lot of times really necessary too, that they will jump in nighttime, after hours, you name it,
and do changes, right?
And they do manual changes, because at that time you do what is needed to bring the site up. This is where the configuration compliance comes into play. Okay.
Exactly. And here you can see the compliance report. Here are all the features that we have defined. With green, you can see the compliant features. With red, you can see the non-compliant features. And in the non-compliant, you can see what are the missing configuration, what is the remediating configuration. So what we should configure in order to bring the device configuration to the intended state. For example, if we see some access list, we will see that this configuration is missing. This configuration is extra, so it is on the device, but it's not in our digital templates. So in order to remediate the configuration, we need to apply this command. So if I can show you a very, very simple example, if we check the logging, for example, the logging at this time is compliant because the intended config is the same with the actual. So if we go to the device and sorry, open the correct terminal. So if we go to the device,
And do you run these compliance jobs on a daily basis? Like what's on a schedule they run just to make sure that device?
Yeah,
Okay.
it's a scheduled job that runs every night. Yeah. So if I go and change the configuration, so I will say we'll put 40 here. So this is going to bring our logging feature in non-compliant. So I will go and run again all the backup intending and compliance. So let me find this one. So since I changed the device configuration, we expect the logging feature to run the job. This job is going to get the configuration ending, and produce the compliance report.
So this is like an incredible amount of work to just build everything on top of Nautobot and have all the jobs, all the
Yeah.
ZTP, the compliance. And you said it's all open source. So can people find these tasks and these jobs somewhere? Can they have their own instances of Nautobot and kind of build and use what you guys have done here?
If I'm not mistaken, Michalis, we have only used open source plugins and everything. The actual implementation, we have not publicized it. I mean, there is a lot of project-specific logic into that. So I wonder if it would make sense to make it public for other people to get. But
at least a couple of jobs or tasks, right? It's like, okay, the ZTP piece or the config compliance, right? And kind of like sanitize, remove any, credentials, stuff like that. But it's like, hey, this is the Python task for Nautobot to do config compliance. Just, you run on a schedule, it goes, connects to the device, gets the config, there's a diff, and it shows you. I think that'd be super helpful.
Well, incidentally, all the jobs that do intended backups, compliance, also the the candidate configuration with secrets and everything, these come out of the box with Nautobot Golden Config plugin. I feel like an advertiser, sorry, but that was actually the reason that we went with Network to Code in the first place, to be totally honest, because they had the mechanisms to make all that almost out of the box. So we started with a big advantage that half of our work was already there for us to implement. The ZTP, that's a view that Michalis implemented with colleagues of ours. The data generation, that's 5,000 lines of code plus the blueprints. Anyway, so yeah, there are pieces that we should consider open sourcing. That's actually a really good remark.
So as you can see, the intended configuration is different from the actual because the history size is 40 instead of 20. And we can see that this is the remediating configuration. We should bring the long history size to 20 because this is our design. And we can apply this to our device. So if we go to config plans, so if we go to config, add the config plan, this is remediation config plan. Let's put a random change control ID. The feature is logging. And the device. This is going to produce the configuration plan. So here we have a configuration plan. We can see the config set. What are the actual commands that we will send to the device? We need to open this config plan and make it to approved, the status to change the status to approved so that we can proceed and deploy the configuration to the network. And now we can deploy it. This will spin up a new Nautobot job that will connect through Nornir to our network device and change the device configuration based on the remediated config. So again, we go to the device. We will see the compliance.
You should have that it's compliant now.
No, not yet, because I need to run again the jobs to get the actual device, the actual config from the device. So I need to go again and run the get backup because I need to get the actual configuration device again, so that Noto would be aware of this change, and then this is going to be compliant.
You're doing that, Michalis, like in the movies where the bomb time ticker goes down to 2 seconds. It's exactly top of the hour, and you will see the green compliant. But yeah,
there you go.
Okay, let's see if the logging get compliant. Yeah. So it's again 20. So we make our device compliant with our design with just 2 clicks. And this is what that's our network configuration management solution. We generate the config through the digital templates. We get the config for the device. We compare them and we produce the compliance report, and then we can remediate the device configuration.
And I really hope it did not go unnoticed that we did not show the ginger templates, because this is where we're hiding the dirt. But yeah,
They are huge.
they're huge.
Yeah, I mean, there's a lot of hidden stuff, right? To make this
Yes.
so easy and seamless, and just having everything managed to note about. I mean, there's a lot of heavy lifting happening in the back. I'm sure, because
Yeah.
it's so smooth and the experience is nice and everything makes sense. So there's a place where
True.
these things happen in the back. So then let me ask you guys, what next for this, right? So you got you got the automation in place. Like what's coming up next for this project?
Version 3, I guess, in some years. Um, right now, the main guy running the thing, the automation piece, is our friend Jordanis. We would have invited him here, but he's vacationing in Vienna. So I guess good for him. Um, there are a few tens of operators running the platform every day, and it's still in the deployment phase. Not all the sites are yet in production, so more and more are being done. Thank you, Panagiotis. We were involved in these projects up to a month ago as Network to Code. We're still supporting the whole thing. We were delivering new automations. Michalis created a really cool single site synchronization that was a big ask for a year or two now. There are a few other workflows that the operators are asking for. These are being handled right now by Jordanis. He pretty much is in the shoes of Michalis, since Michalis joined Network to Code. And I believe this is the current state of the project.
Also, also there are lots of other features that we have been implementing instead of except of configuration management. We implemented firewall rule management, automatic OS upgrades, device lifecycle. We get the CVEs for each software that we have in the network automated from Cisco Portal. VPN management. We can create VPNs on demand, but we don't have the time to show you all this functionality. But there are lots of other things that we have implemented, but we don't have time. Maybe in another time to show you.
No, I mean, yes, I'd love to have you guys back actually to go into a bit more details if you have time. But and also, if you can publish something to make something on GitHub public for folks. I mean, Ioannis was suggesting here the process to trigger the ZTP
ZTP, yeah, that's
would
true.
be
That's a
interesting, maybe to
really
publicize. So if we can get folks, like a GitHub repo, a public one, there's like just a bit of story of all like exactly what we've talked today, and then a couple of jobs for Nautobot like ZTP, and even if it's built in the config drift or the golden config thing, if it's built in Nautobot with that plugin, just to mention that, I think that'd be fantastic because we can then point people to that. You have the video, right? Here is how we show what you folks have done, and then you want to do the ZTP, it's like right there.
You know how it goes. I mean, we're doing that every other day now that we're in Networks to Code, and we tend to forget sometimes how magical it can feel. It's, a given for us. I mean, if someone asks me, configuration management, I will say, yeah, Golden Config does it. And I don't even think about the effort that has gone behind that. Thank you, Ken. That's my director. He's the creator of the Golden Config. But yeah.
All right. Well, we're a bit over time here. Thank you so much, you guys, for this. Any final words before we wrap up?
I have mentioned all the people that I had written in my small paper, so I'm good. Thank you very, very much, Adrian, for that, though. It was a really nice
Thank you.
experience.
I really appreciate you inviting us.
No,
I really
definitely.
appreciate that.
Really, really happy that you guys made it. Like I said, let's make sure we bring you back. But next time, let's have a public GitHub repo with at least some of the jobs to show folks. I think that'd be
Makes sense.
fantastic.
Sure.
All right,
Sure thing.
perfect.
Makes sense.
Well, thank you all for watching. And see you next week. We're gonna have Abhijit Bakale, and we're gonna talk NSO automation, creating services with NSO, all of that, config management. So see you then. But in the meantime, big thanks, Michalis, Nikos. Thank you again so much. Thanks everyone for watching this. See you guys on the next one. Take care, folks.
Bye bye.
Thank you very much. Take care. Bye.
Bye everyone.